Dear students, in previous video I gave the scanning electron microscope and tunneling electron microscope. You all understand that. Now I give the basic ideas about scanning tunneling microscope and atomic force microscope. Scanning tunneling microscope scanning tunneling microscope with the basic principle of tunneling effect, which is quantum mechanical phenomena. Here, the tunneling effect is nothing but the particle having energy less than the energy barrier which crosses the barrier. The energy barrier which crosses the barrier. Let's give the basic example of this. And tunneling. What is tunneling?
Mr. X is standing in front of McDonald's. Let's say the precise location of Mr. X is 5 meters away from McDonald's. Now let's assume that we are in a quantum world, and the dimension of everything around us is in nanometers. In this case, it's very difficult to say the exact position of Mr. X, because in quantum mechanics, every particle is located based on its probability. So instead of saying Mr. X is located 5 nanometers away from McDonald's, we will have to say the probability of finding Mr. X is maximum 5 nanometers away from McDonald's. However, Mr. X can be present either 3 nanometers or 7 nanometers away from McDonald's. It's just the probability. Now, based on this, let's try to understand the quantum tunneling effect. Let's say Mr. X is trapped in a well 10 meters deep. Now, the well is so deep, it's impossible for Mr. X to reach on the top of the well. However, the scenario will be different in quantum mechanics. Let's say the depth of the well is 10 nanometers. In this case, because location of Mr. X is given by probability, Mr. X will have some probability to reach on the top of the well. And this phenomenon is known as the tunneling effect.
This phenomena is known as tunneling effect. The probability can reach the barrier, which is tunneling. Tunneling effect, the person which move from one person to other person which energy less than the barrier, the tunneling effect. The scanning tunneling microscope has small nanoscale size strips which comes very close to the sample. So the tip is very close to the sample which are observing the tunneling. So while in tip and sample, why electric potential difference applied between the sample and tip, the electron from the sample or tunneled to the depth. A small electric current produced by the tunneling electron which is amplified and sent to the computer. Based on the electric current produced. The electric current is amplified which is observing the sample. Depends upon the temporal sample distance the tunneling current produced. The scanning tunneling microscope, the magnification is nearly 100 million and resolution of the observation is 0.1 nanometer, and imaging the surface is atomic level. In deep level observing the images, and it provides the three-dimensional profile. And now it got the from the scanning tunneling microscope Nobel Prize 1986 got scored. Next I move to the atomic force microscope. Atomic force microscope works on the principle of attractive and repulsive force. Atomic force microscope in 1986 is observed. Atomic microscope, the basic principle behind this is at atomic level of attractions and repulsion force on the atomic level. If two atoms are present, one is positive protons and negative electrons are attractions between the two levels which is come close to them. If two atoms are separate distance are placed which is attracted or repelled between the electrons as small strips. Again, the scanning atomic force microscope is also same types of is advanced versions of scanning tunneling microscope. The tip can be attracted or repelled from the sample electrons. The old version of atomic force microscope used as STM tip. The same scanning tunneling microscope tip are used for atomic force microscope. In later, they used as the laser as well as the mirror. The laser electrons are applied towards the mirror In cantilever depressions, the atomic tips are observed from the sample. The movement of cantilever detected by the laser and detector. Here, atomic force microscope, they observe the three areas is contact mode, non-contact mode, and tabbing mode. Repulsive or attraction based on that the contact mode are observed. In contact mode, distance between the probe and sample is very short. Cantilever is repelled. Resolution is very high, and shorter distance probe may collide with sample, and sample and probe are damaged in contact mode. So in contact mode, damage is observed. Non-contact mode, distance between probe and sample is very large. Cantilever is attracted, means we observe the non-contact mode, and resolution is low. Sample and probe is not damaged. And tabbing mode, distance between probe and sample is intermediate. Cantilever oscillates. Resolution is better than non-contact mode. So these three modes are important. Thank you so much. I hope you understand the scanning channeling microscope principle and atomic force microscope. If you have any clarifications regarding this, don't hesitate to contact. Thank you.